Okay. Good. We can see okay? Yeah. All right. So domain and range. Right, we'll get started now. Abir and Sophia, ready to start? Yeah. Oh, goodness. Okay. So in the Charles exam, from time to time they have questions asking you what the domain and what the range of a function is. So this isn't something we talk really much about in the IFY. So first we have to explain what each term means. So the domain, now I'm giving you the simple definitions that will do for the multiple choice exam, okay? So these are just like basic definitions. The domain of a function f is just simply the set of all allowed values of x. In other words, simply put, the domain is the values of x you're allowed to use. That's all it is. Could be all real numbers, but depending on the function, it might not be. Okay? So that's the domain. The range is all returned values of the function. So simply put, that just means all the y values you could get back as an answer. Okay? So let's have a look at a simple example just to get the ball rolling, and then we'll go on to harder ones. Can I scroll down? Yeah? So our first example is, what's the domain and range of this function, fx equals root x? Well, this is example 1. Right, so what's the domain and the range here? Well, yeah, what's the domain? Including or not including 0? Including. So it would be written in the Charles exam, they usually write it in set notation form, so it'd be 0, infinity. Also in the Charles exam, I think they use different brackets. They use like these. I think the Charles exam might write it like this. They use a different bracket for open, I think. Anyways, when you look at the exam, you'll see it. You can figure out what the symbol is for open, because when you include infinity, it's always open. Okay. Now, what's the range? Now, think carefully about this. What are the possible answers you could get back after you take the square root of a number? What numbers? Including or not including 0? Yeah, in fact, it's the same. In this example, it's the same. You get back positive numbers, potentially 0. Okay? Right, now let's try another example. Example 2. Let's take fx equals x cubed. What's the domain? All real numbers. What's the range? All real numbers. Yeah? Yeah? You got that? I can scroll down? Yeah. Just a little bit of vocabulary. If you have a situation where you get all real numbers, there's a word you can use to describe that situation. we say f is, if you have this now, all real numbers in the range, you can say f is onto, or another word that's sometimes used is surjective. The only reason I'm telling you this is because I could imagine a question like this in the exam. They could say, which of the following functions is surjective? So I'll give you an example. Example 3, which of the following is surjective? So your first function could just be fx equals x squared, fx equals 1 over x, or fx, let's say, equals square root x, and finally we'll say fx equals x. So let's check them one by one to see which is surjective. What's the range for the first one? No, it is not. The range of the first one? Positive numbers. Range of the second one? Except 0. All real numbers except 0. Range of the third one? It's all positive numbers again, including 0. And the range of the last one? All real numbers. So which is surjective here? The last one, D, is surjective. Okay. Example 4. Let's start making things a little bit harder now. So what is the domain of, let's say, 1 over x squared minus 39x plus 374. Why did I pick such? No, don't be such a jerk, Stephen. Sorry, let me pick nicer numbers. Minus 5x plus 6. I don't know why I did that. Okay. So we have to figure out the domain of this function, and already I see you're getting your calculators out, so you know what's the first thing you should do here. Factorize, yeah. Yeah, you get x minus 2, x minus 3. Okay, so how does that help us? How does that tell us what the domain is? Yeah, so what would we say the domain is? Except 2 and 3. Good. Now, it starts getting a little bit harder if now I was to ask you, example 5, the same question, but I said what is the range of the same function, fx equals 1 over x squared minus 5x plus 6. Same function, I ask you, what's the range now? Now that's not as obvious here. It's not clear. We have to do some calculations to figure that out. So I'm going to show you a technique for figuring out the range. Okay. Can I scroll down? Yeah, sure. Yeah? You got that? Yeah? So, how do you get the range when it's not obvious? So in the previous examples we've done, there was nothing to do. It was all pretty obvious. This is all positive numbers. These are all, it's nothing special. Although it's not obvious here. Could you get positives? You could. Could you get negatives? You could. Could you get 0? No. No, because the only way a fraction could be 0 is if the top is 0, which it can never be. So, okay, we know we can't get 0. But could we get like the number 1? We don't know. So we need a process here. Here's the process. Step 1 in the process is simply to make y equal to your function, so that's all fine. Step 2, you need to rearrange it so it's equal to 0. Okay, so you need to get it in the form of equal to 0. Like that, okay? So you cross multiply y x squared minus 5x plus 6 equals 1. Okay. And you also have to pretend y is a number, that it's constant. So just pretend for a moment that y was a constant, it was a number, like the number 2. If you had a number in the front of the brackets, what would you do next? You'd multiply it in, wouldn't you? Okay, so you'd get yx squared minus 5yx plus 6y equals 1. And again, pretending y is a constant, what would you do next? Well, you'd bring the 1 over, and you'd have yx squared minus 5yx plus 6y minus 1 equals 0. Now, if y really was a constant, what you would have is a number here, x squared, yes, plus a number here, x, and if y was a constant, you could add it together. So at the end, you would have a number there, equals 0. So the final step is you ask yourself, for what values of y will the above be solvable? Not even equals 0. I'm not even asking you for the solution. Please note, I'm not asking you to solve the previous equation. I'm simply asking you for what values of y will the previous equation be solvable. But I'm not asking to solve. Just when will it be solvable? When what? When y is 0, it would be unsolvable because the x has disappeared. So you couldn't possibly solve then. Ah no, you see, your brain isn't fully powered up. Let me help you out then. How can we tell when a quadratic is solvable? Yes, when it has roots. And how do we know if it has roots?
It's greater than 0.
What's greater than 0? No, discriminant. Alright. So, in this question it would be solvable when the discriminant is a bit more precise. Equal or greater 0. That's when it would be solvable. So that means b squared minus 4ac, that needs to be positive. Okay? That's 25y squared minus 24y squared, is that right? 4 times y times 6y? 24. And then minus is plus 4y, greater than or equal to 0. Have I done that right? Yeah? Yeah. So that's y squared plus 4y greater than or equal to 0. That's y times y plus 4 greater than or equal to 0. What are the two roots there? 0 and minus 4. And are we wanting above or below? Above?
Is it minus 4 or
Thank you, Amjad. What is it? No, it's plus. No, this is right, isn't it? Yeah, this is right. Yeah. So the answer is y has to be less than or equal to minus 4 and y is greater than or equal to 0. That's the range. However, be very careful here. Arya said that the y could be 0 here. But if we go very back to the beginning, we can see that y can't be 0. Remember, for you to be able to do this, it has to be quadratic. And it's not quadratic when y is 0. So in fact, we need to delete the y could be 0. But you also knew this at the beginning, because at the very beginning we said one value we can't have in the range is 0 because the top can't be 0. So the final answer would be minus infinity to minus 4, and then not 0 to infinity. Why isn't my pen writing here? Oh, my... Oh no, it's plugged in. Okay, everything's powered up. What's going on here? Well, while it's catching up, you can write the set down. -4 open to infinity. Start again. Minus infinity open to -4 closed. Union 0 open to infinity open. The heck? Come on, dudes. No, the zero's definitely open.
I can have 0.
I can use my mouse pad, but that makes really bad writing.
Maybe a reason. You can use this pen without.
No, I've got it set to ink, haven't I? Come on, wake up. Oh, there we go. Okay, right. We got that one. So I'll write it down here. Minus infinity to -4 closed. Union 0 to infinity. Okay. That's a difficult one, maybe too difficult for the MCQ, but I'll give you one that's like this but a bit shorter, okay?
Wait, so I don't understand
Yeah.
how the 0 is open if we say it's not equal to 0.
Yeah,
It's 1 over.
it's open because we can't have 0.
Oh, it's closed when it includes.
Yeah.
Okay,
Continue. Yes, you have this?
yes.
Yeah, okay. Let's have a look at a little bit of an easier one. Let's just say I have fx equals to, let's just say 1 plus x over 1 minus x. Domain and range. Okay, so first question, part A. What's the domain? Right, so what's the domain here? Yeah, all real numbers except 1. Good? Okay. B, let's get the range. So the process is we begin by saying y equals 1 plus x over 1 minus x. We rearrange, we get y minus yx equals 1 plus x. Yeah? So we have to rearrange this equals 0. I think I'll bring everything to the right. So I'll get 1 plus x plus yx minus y. Now remember, we're pretending y is constant. So what could I add together here? Well, I could add x and yx. So what would I get? 1 plus y x. Yeah? Then plus 1 minus y. Okay, now time for the tricky part. What type of equation is this? Linear. When is a linear solvable? It is not always solvable.
Except when it's
No.
It's constant.
Yeah, well, so for this, so okay, look, mx plus c equals 0. When is that solvable? Come on, guys, when?
Oh,
What
it
is
has,
x is not equal to
when it has only 1 root.
I know.
Doesn't equal to 0.
What doesn't equal 0? Yeah. Yeah. You can solve this always, except when m is 0. Can you find x when m is 0?
No.
No. So this is solvable as long as y does not equal minus 1. So the range is all real numbers except minus 1. Yeah? All real numbers except minus 1. That's the range.
Can you explain how you group the 1 plus y? That step.
Yeah, just x plus yx is 1 plus yx. Because I took the 1 and the y out. And then, yeah. This is definitely the right length for an MCQ question. Because it's only 1, 2, 3, 4 lines. Okay, so this is like a ideal MCQ question. The other ones they'd like to ask are with sine and cos, which we haven't had a look at yet. So let's have a look at some sine and cosines and tangents, perhaps. Okay, can I scroll down? Yeah. Okay. Next example. Let's say y equals 2 sine, I don't know, 3x plus 1. What's the domain and what's the range? Alright, so first question is what's the domain? What's the domain here? Yeah, you can use all real numbers. There isn't a value you can't use. Right? Okay, now a little bit harder. And you'll need to think back to semester 1. Semester 1 when you were making the graphs. Because the meaning of range, yeah, it's all the possible y values. So as you said, Amjad, it's the minimum and the maximums. So if you think about your sine graph here, 2 sine 3x plus 1.
Minus 1, 2, 3.
No. No. Oh wait, sorry. Yes. What is it, the range? Minus 1 to 3. Yeah. Because what will happen is this sine could potentially be as big as plus 1 or as small as minus 1. So the biggest this could be is 2 plus 1. And the smallest it could be is minus 2 plus 1, which is minus 1. So the range of this function is minus 1 to 3. So basically you just replace the sine and the cos with plus or minus 1 and you've got the range.
Doesn't the 2 make it shorter?
Yeah, but the range is only vertical, so we don't care about what happens horizontally. Yeah? Now, what about this one? Y equals 2 tan 3x plus 1. What's the range here? Anybody remember the graph of tan? Graph mode. Computer. Plot tan x. Okay, Google. Plot tan x. Yeah, well, hang on. He's going to ask Siri here what the plot of tan x is. Have you got your graph?
Yeah.
Yeah, what is it?
It's hold on. It's taking ages, I don't know.
404 error?
It's like
It's like this.
yeah, exactly.
So what happens is the tan graph stretches from minus infinity to plus infinity. So in fact the range is all real numbers. Okay. Got that? Okay. Now on to a trickier one. What is the domain of, let's say, fx equals sine inverse, let's make it a little harder, 2 sine inverse x over 2 plus 1. Now what's the domain of this? Or what's the complication here? Yeah, you see, sine and cos will take any value. But sine inverse and cos inverse won't take any value. Well, does anybody know what value sine inverse and cos inverse will take? It can take negative too. No? What is it?
Quadrants.
No?
Only negative.
No. You can take positive. Yeah. No.
No, only domain wise. Only.
Is it from?
Yeah, domain only negative. It will only be on this
No,
side.
no. So, we're getting closer, but no. Sine inverse and cos inverse can only take values between -1 and 1. If you were to type in sine inverse of 2, you'll get an error. If you type in sine inverse of -2, you'll get an error. No, yeah, do check.
Oh, right.
Yes.
It's always.
Yes,
P
yes,
over
yeah.
2.
So the domain means that you can only input here between -1 and 1. You can include -1 and 1 though. But what does that mean for x? We're not saying that x is between -1 and 1. What we're saying is x over 2 plus 1 is between -1 and 1. And you've seen this exact problem in semester 1. Okay, there is the advantage of making your own maths workbook is I can deliberately choose with good reason the questions that are in it. So you've seen this one in semester 1. How do we solve this? First we
Split it.
multiply. You could split it, but I like to keep it together. We'll multiply it by 2. So we'll get -2 less than or equal to x plus 2 less than or equal to 2.
Minus.
And then what do we do next?
Minus 2.
-2 onto everything. So we get -4 less than or equal to x less than or equal to 0. So the domain is -4 to 0. Now if this was an MCQ question, you can bet that one of the answers in it will be this. You can bet that. One of the answers will be this. Maybe Aria, they'll go with minus pi to pi as well, since you suggested that. Oh, and somebody said minus infinity to infinity. So, it could be something like this is the answers. Yeah. Okay, let's see. The range, yeah. What would be the range here? So, sine inverse is the opposite of sine. You'll need to think about this for a moment. All right. If you take the sine, what goes into a sine? An angle. And what is it equal to? It's equal to a ratio, a fraction. So, like for example, sine 30 degrees is a half or whatever. Okay. So, in other words, what you put into sine is an angle, and what you get out is a ratio. It's the opposite for sine inverse. What do you put into sine inverse? A ratio. Which is why it should be between -1 and 1. And what comes out? An angle. Now, not every angle comes out though.
0 to.
Yeah.
0 to.
You could check this on your calculator, okay? If you're not sure in the exam, the easiest way to check this is just quickly draw a circle here. Okay? And you want to see, is it possible to get all the different angles here in the circle? And a very, very quick way to check this is you could just type in sine inverse, and I would check 4 different numbers. I would check 0.25, 0.75, minus 0.25, and then sine inverse minus 0.75. So I know that if you type in sine inverse 0.25, you'll get some angle in this quadrant. You get whatever it is, 20 degrees or something. Whatever, yeah, something like that. If you type in sine inverse minus 0.25, I know that you'll get some angle here. You'll get a negative angle. If you type in sine inverse 0.75, I think you'll also get an acute angle. Yeah? And if you type in sine inverse minus 0.75, I think you'll also get a negative acute angle. So what quadrants are sine inverse returning to you? Not just positive and negative up to 90. So in other words, positive and negative acute angles. Yes?
Yes.
So, if I go back up to this guy, potentially sine inverse could give me a minus 90 up to 90. However, I'm multiplying this sine inverse by 2, so my answer could potentially be
Minus 180.
minus 180 to 180. So that would be the range here. Okay. And now that last example is a good Charles example, asking you for the domain and the range of 2 sine inverse x over 2 plus 1. They seem to prefer asking you domain and range questions for sine and cos. So this is a good example one to have. You have that one written down? Yeah. Let's do one more. Okay.
Can we expect calculus stuff in Charles?
I've seen it a couple of times, but technically speaking, I think all the questions are possible to do without calculus. Although sometimes, because like for example, they might ask for the maximum of a quadratic.
Which you can do in the
Yeah. They might ask you for the slope of a tangent to a circle. You know. I continue? Let me just give you one to try here before I do it. I want Fafra. Come on. No talking when I'm talking. Fx equals root x squared minus 29x. Yep.
Do they have a math exam for the lesson?
I don't know. Do they? No.
It's just Charles?
Charles? And I thought someone said there was another one.
LSMU.
They have maths exam. Yeah. Okay. Right. Fx equals root x squared minus 29x plus 198. What is the domain? No. Because if I was to sub in a number like minus 100, I wouldn't get an answer. Or maybe I would, I don't know. It could. You have to do something to figure out what the domain is. So what's the key step to getting this started? Does it have factors? Yeah, what are they?
X minus 11, x minus 18.
Yeah, but how does that help us get the domain?
Yeah, it should be greater than 0.
Yeah. You need this to be greater than or equal to 0, because you can't take the root of a negative. So, there's 11, there's 18. So what's the domain? It's this and this.
Except 0.
Minus infinity
To 11,
to 11, close, and
18,
to infinity.
Except 0. Oh no.
You can have 0. Yeah? Yeah. My next question now is what's the range? Yeah, what's the range here?
0 to infinity.
all real numbers.
Not all real numbers, no. So the question is, because of the square root, we know that we will never get a negative answer. Now, could we possibly get 0? Could we get 0 here as an answer? Yeah, because it just means the quadratic will be 0. For what value of x would we input to get 0 as an output?
11
11 or 18. So we could certainly get 0. Could we potentially go all the way up to infinity? We could. We just simply keep increasing the x past 11 or 18 and we will climb up to infinity. So the range is 0 to infinity. Okay. Okay, so just the very, very last one now. There's one question I forgot you didn't see. I just want the range of x squared plus 2x plus 5. What's the range of that function? I'll give you a minute. Any ideas?
4 to infinity.
4 to infinity. Okay. So, what you should do here to get the range is to complete the square. So you get x plus 1 squared plus 4. What is the smallest value you can get here?
4.
It's 4. Could we get 3 as a possible answer?
No.
No, because if we got 3, it would mean that this guy was minus 1. Is there any input of x that would make that minus 1? Of course not, because it's a square. Okay, so we have to begin at least 4. And we could get bigger and bigger. In other words, the range is all values from the minimum upwards. So the answer here is 4 to infinity. That's the range for this one. I'll give you the worksheet now. So just there's a few minutes. Try these for 5 minutes, and then you can take a 10-minute break before your chemistry.
So we close the window now, please.
Yes, okay.